So hey guys, welcome back to my channel. So today I'm be continuing the course of internship, and the course of internship is of this is of task 3, and I'm showing the task 3, that is, yeah, this is iris flower classification, and the iris flower dataset consists of three species like Setosa, versicolor, and virginica, and this is a famous dataset, and I will be predicting or classifying the iris flower, and this is my offer letter of course of. So yeah, so first we will check the data, how the data is. Okay, so the data is I'm having is sepal length centimeter, sepal width centimeter, petal length centimeter, petal width centimeter, and species. So here we have to classify the species according to the features I am having, that is sepal length, sepal width, petal length, and petal width. So this is my code, that is classification.ipynb. It's taking time. Please load it. Yeah, so this is my problem statement, that is to classify iris flower according to the species. So for any data set, I mention every time that for any data science project or task, we have to go for the process or steps, that is data gathering, data cleaning, data transformation, data integration, data reduction, data normalization, data splitting, data visualization, and documentation. So uh, yeah, so this is my data set, and I am importing the libraries, that is import pandas as pd to import the libraries with the data set. It's connecting to the kernel. Please load it. Load it. So my Visual Studio Code is taking much more time than earlier. Why? So I don't know. uh, yeah, so now I will load the dataset in df. So calling the df, that is sepal with petal length and petal width and species. Now we'll check the info. So in the info, that is, there are float values and object is species, and there are no null values as per the numbers is showing. Df dot describe, that is sepal length, sepal width, petal length, and petal width, and it's describing the mean value, standard deviation, minimum and maximum value. Checking if missing values are there or not. As there are no missing values, so we can move forward to duplicate values. Now moving on to the duplicates. If there are any duplicates, we will remove it, and there are no duplicates. So as there are no duplicates, we can move forward to outlier detection and transformation. Now we will import the libraries required for the outlier detection. So we'll directly go for the box plot, so that we can check how many data points are having as a outlier. So now we will check the outliers of the four features, that is sepal length, sepal width, petal length, and petal width. It will show the graph as a median, quartile, and interquartile range, and we can say that this data point is not under that range, and if it's not under that range, it will consider this as an outlier. So now, why it's taking much time? So yeah, here this is a graph of outlier box plot. Yeah, so in this I can say that sepal width is having much more data points outlier. So there are some outliers in sepal width centimeter. So as there are outliers, we will move forward to the outlier transformation, as clustering are much more sensitive to outliers. So we will first check the that what is the distribution of this feature, that is sepal width. So here we are seeing as a normal distribution only. So we'll go for Winsorization. So what is Winsorization? Winsorization is a technique where we keep the data points in a particular range so that it will not form as an outlier. So I kept in the limits of 0.05 to 0.05, and now if I check the outliers, there are none. So as the outliers are removed from the data is now completely pre-processed. So now this is the visualization for clustering purposes. I had just created the cluster of these species, and now from x value, that is 0 1 2 3, that is features sepal width, sepal length, petal width and petal length, and then I call the function k-means to create a cluster according to the range, that is I am having 1 to 11, and it will automatically form. This WCSS means within cluster sum of squares, and it will say that how much clusters we need to do. Now it's plotting the elbow method. Elbow method shows that how much clusters we want. According to that, we can create the clusters. Yeah. So this is a graph where this and this part, or this line is having much more turn, or having an elbow, as the name suggests, that is the elbow method. We can consider this as a cluster, and this number is called 3 2 3 4. So this we will consider as the cluster, and here I kept cluster as 3. Now if we plot the cluster, our cluster will form like this, that is this, which is having a yellow centroid and red blue green as the species of iris. So this is a cluster, this is a cluster, and this is a cluster, and this yellow part is centroid. So here we classify the clusters as the iris species according to the features of the flower, and this we completed the iris flower classification of course of task 4, but for me that is task 3 because I have to complete the movies prediction also. So this was my offer letter, and I had also uploaded in the GitHub link, same the code I have uploaded. So if you want to suggest any changes in my code or any new content if you want to show, you can comment me in the comment section, and I will put the GitHub link in my description box. You can go and refer it. And that's for today. I had completed total task 3 in my Codesoft internship, and it's been completed for my internship completion. But I will do two more are there, no? So I will complete these two also, that is task 2, that is movies reading prediction, and task 5, that is credit card fraud detection, so that it is for our purpose only, and we will know about our experience, that how much we know. So it's for our purpose only, and this way I had completed my course of internship task 1 2, task 1 3 and 4, total 3 tasks. And if you like this video, share, like and subscribe. Thank you.